So hello guys, welcome to our video series for electrostatics problems. Okay, so now today in this video I am solving a problem on finding the net forces for different geometrical structures. So in this video I am solving this for a square. We can also solve this for hexagonal structures where different positions charges will be given. We have to find the force maybe at the center, maybe at some other points. Maybe triangular questions will be given, charges at here, here and here. We have to find the net force here. If there is not given any charge, so we consider a test unit positive charge. So this is the point. So in this particular question, we have four charges: plus q minus q minus q plus that a b c d plus q minus q minus q, right? We have to find the net force at the center O, where the charge is plus q, capital Q. So we have to find the net force at this point. I am just telling you about the theory so that you can solve the other problems like hexagonal and triangular and some any rectangular. So you just be careful in finding the distance between the charges and finding the directions, right? This is the most important thing. So let's solve. We know that force is a vector quantity, right? So vectors doesn't add like scalars, like 2 plus 3 equal to 5, 1 plus 2 equal to 3. It's not like that. Vectors add like vector superpositions. So vectors, how the vectors add? It add up like if I have a vector A and a vector B, right? And the angle between them is theta. So the superposition vector will be like this: a plus b, that is the magnitude will be a square plus b square plus 2ab cos theta. Theta is the angle between the two vectors, right? So now we can do it by a trick. Okay, as you know that tricks are more important, but also the concept is very important behind that. So let's find the forces. Before finding the forces, what is the electrostatic force? The force formula is 1 by 4 pi epsilon naught q1 into q2 by r square. This is also a very important question, that force depends on charge how and distance how it depends on distance, how it depends on charge, and this constant quantity. Okay, so now in this question we have four charges at the corners of the square. So this is the diagonal, this will be root 2, you know that. As the side is a, so this will be root 2. As the units are not given, we will consider a as meter and q as coulomb. Okay, SI unit, you know that this is the standard unit, right? So the sides are given as a. So first I told you that we will find, if you find force, you need the charges and the distance. The charges we have got plus q minus q minus q, at the center is plus capital Q, and the distance is needed. We can see that the distance of all the four charges from the center will be same because it's a square. As it's a square, all the four charges will having the equidistance from the center, and we have to find that. So we in order to find that all are the equal, that is equal to, this is the distance is the half of the diagonal of this right angle triangle. This is a, this is a. So the so this hypotenuse will be root 2a. Okay, if this is root 2a, so the half will be root 2a by 2, that is equal to a by root 2. Okay, and we know that 1 by 4 pi epsilon equal to 9 into 10.9. Okay, we'll use that in the problem where the numericals are given, but here in this kind of problems numericals are not given. So we'll find the general formula which will be used if numericals are given, like numericals. By saying numerical I mean that q will be given 2 coulomb, capital Q will be given 5 coulomb. So you can put the formula 1 by 4 pi epsilon can be substituted as 9 into 10.9. Okay, so first let's find the forces. Also we have got the charges and the distance of force will be 1 by 4 pi epsilon naught q1 into q2 by r square. So this I have got by substituting the formulas. You can see that, look after it. Okay, so now come to the figure. This is a positive charge, this is a positive charge. So as this charge is positive, they will exert a repulsive force but this is a negative charge, this is a negative charge. As this is positive, they will exert an attractive force. So force due to F or charge at A will be repulsive in this direction, that is taken as F1. Force due to third charge at O will be attractive, that will be denoted as F3. Both are parallel. Similarly, F2 and F4 both are parallel. So now, as F2 and F4 parallel, F1 and F3 parallel, we know that vectors which are parallel, that means they are in the same direction, moving in the same direction, so they can be add off. How? Because the vectors are parallel, the angle will be 0, right? So if 0, cos theta will be 1, so a square plus b square plus 2ab, that is a plus b whole square, and the root over of a plus b whole square equal to a plus b. So we can simply add off. If the angle is 0, that means if parallel, we can simply add up the vectors to find the net vector. But if they are perpendicular, the net vector will be in the direction in between them. If they are perpendicular, the net vector will be direction in between them, like this. Okay. If the vector is this, they are perpendicular. The net vector is in between. Okay. So first, if denote the net vector of f1 and f3 is f5, f2 and f4 is f6. So f5 will be f1 plus f3, simply added because they are parallel. I said that, so you can simply add. Simply add means all are having the same magnitude, so we'll only multiply 2. Like that, you can find f6. Okay. And as I said that if they are perpendicular, so the net will be, I have not derived it, f5 square and f6 square and 2f5 dot f6. So f5 and f6 having perpendicular, so the angle between them is 90 degree, and we know that cos 90 equal to 0. So this becomes root 2 times f of 5. Why f of 5? Because f of 5 and f of 6 both have the same magnitude. Okay, so we'll find that it's root 2 times f of 5, and we have f of 5 magnitude are 1 by 4 pi epsilon naught 4 q, capital Q into small q by a square. So it's root 2 times 1 by 4 pi epsilon naught 4 capital Q by q a square. That is the net force. Okay. Why I am keeping this term everywhere? Because in the problems I have, if the numerical problems, I have to substitute this. That's why I am not cancelling the force, so that it will be easy for me to do the numerical problems, and to derive general problems it can be also used. Now the direction, the net force of F2 and F4 in this direction, F3 and F1 in this direction. The net force will be in this direction. Okay, because they are having angle 90 degree in between them, so the force will be in between them, that will be in the in direction. If the forces are like that, so the net force will be in this direction. How I am saying that? Because if you are pulling something like this, the net force will be in this direction. But if the force like this will be in this direction. So always the resultant force lies in between the two vectors. Always. If 90 degree, it will be just middle of in between, that is in 45 degree. Okay. So if direction is asked in the examination or in any entrance exam, so you can get as 45 degree it is. We can just say that it is downwards in the figure, but if axes are given like this, x and y, so you can say that it's in the negative y direction. Okay, if our square is like that, so the force will be in the negative y direction.